Hi guys, I am Stew Redfield. I am currently the Vice President of Cloud Infrastructure and Architecture for Digital Glue. One of the things that brought us here, as well as helping sponsor it, is our Creative Space platform, which obviously lives on ZFS, and love it, love it, love it. So in all of that, we've had the opportunity to actually test dRAID alongside zRAID. And as I've been stepping through it, there are some idiosyncrasies that hopefully we're trying to figure out. So I'm not going to go through the whole dRAID presentation from last summit because I don't remember it all. But it's in the slides. So, and thankfully to Michael who put all this stuff in here to start it all off. But the concept of dRAID versus RAIDZ or traditional RAIDZ type of environments. And we have the opportunity to actually start really testing it to see if it is as performant, which for most parts it is, but it also has a few idiosyncrasies that we're trying to sort out, whether it's, you know, a Linux level thing, whether it's a ZFS thing, or whether it's, hey, just how we are evaluating how dRAID works is a little bit different. So I'm going to drop right into the testing stuff, and hopefully we'll be able to have, and not have the, hey, we're going to demo something live and everything breaks. So it worked 3 times this morning. It worked about a dozen times last night. So we'll play it by ear. All right, so Supermicro chassis, 4 JBODs split across 2 HBAs, or JBOD access. I've got a Western Digital Data 102, Data Store 102. Obviously 102 drives in it. The one we're going to be testing with has 78 18 terabyte drives in it. CPU specs, memory specs. It's Ubuntu 2204 on the 6.8 kernel. And I've tried it with both 225 and 226 for the OpenZFS versions. If anybody wants to read the quick details, this is the setup that's consistent across everything for this test. Anyway, so first scenario, which is the one we'll actually replicate in the conference, is 72 data drives in a 6x12 setup. And similarly, the dRAID, which I think is set up exactly the same way based upon the configuration set. And then the scenario 2 is one of our production level ones that are running this as well. So, simple create for the dRAID on top, level 2, with 12 spares against 102 full devices. And because this is multi-pathed in, obviously we're running the mapper devices. Similarly, the normal zRAID piece, same thing, just in 6 drive chunks. So in my mind, and according to all the documentation I have been able to digest, that's where we live. So in addition to some of the standard IOZone and FIO testing, there's a tool called SPIT. It's written by a guy who used to work for a company that's now defunct called Myriad. He spells his name Stew wrong, but other than that, it's a great guy. It really exercises drives, and it has a lot of statistics in it. And I'm not going to go through everything with you guys on this because each cycle can take up to 15 to 20 minutes. So, but I do have some of the reference information there. Obviously FIO as well. So these are the exact tests I ran, and the exact tests will run for some of this stuff in a little bit. So before we go into actually doing a live one, this is actually, I ran this last night, and the spit whole run ran 111 seconds. The exact same configuration in dRAID mode took 227. So there's something amiss in there. Why, how, doesn't really matter yet. The FIO test, again, similar things. 58 seconds versus 3 minutes 23. And you notice almost all of that is in the real-time space of it. User and system are both pretty similar, at least for all the random testing. So one of the things that I was doing during this is while it's running, I'm running zpool iostat against it. And you can see on the RAIDZ, that 59 second, you'll see in the 2.5 to 6 gig range of traffic. On the dRAID, it's presenting back less than a quarter of that. Whether that is how the iostat is recognizing the dRAID performance or throughput or anything else, don't know. That's why I'm presenting it, but it seemed anomalous and it's pretty consistent. But if you add up all the math, they all spin the same amount of data all the way through. So, in reality, this is against that 78 drive one. So, it's going to build the RAIDZ. Building. It's going to tell me to start the iostat once it's done. Okay. Start that. And now this is running that FIO test that was on the previous slide. And this will take about a minute. And you'll see over here, punch that up a little bit. You'll get that 6 and 7 gig every couple second pops. Great TV. I understand watching log files is kind of our business, but all right, so 25 seconds left. And I'm using FIO just because it's shorter, and for the presentation, I can run this all day if anybody wants to see it in the background throughout the conference. All right, so that one's done. Took 57.8 seconds. That's going to go rebuild it as dRAID. Hey, typing error. It's all about creating things.
What is the file throughput
number? So the question was, where are the FIO numbers? Yeah. On the right, that's the throughput that FIO is saying, or sorry, iostat. Oh, I'm sorry. Pop that up.
So 2 gigs a second of read?
2 gigs read, yep. And 720 write. And it's in the presentation too from an earlier test.
So for those reads, do you see them showing up on the iostat a lot, or is it mostly from cache?
Mostly from cache. In the spit testing, you actually see the read bandwidth fluctuate through because I run it at a much higher level, so it's actually breaking over the memory. But that can take 15 minutes a cycle, and that's really boring TV. So, yeah, that one hasn't finished the thing. So that's about 3 minutes. So that's the reality of what I'm testing, if it's valid or not. Alan, go for it.
So what I'm seeing there mostly when you're doing the file writing is you see ZFS aggregating the writes in memory and flushing them out every couple of seconds, and you see some seconds are
Big
zero,
specs,
even though we're doing all these async writes.
Yep.
And so that's what I expect. Part of that is also that ZFS is probably aggregating those into bigger writes, and that's working nicely. With dRAID, every write is always full stripe, unlike in RAIDZ.
Right.
And I think that might be why, like when we're doing the dRAID one, we see the writes are
consistent.
slower, but it's happening all the time because there's always a transaction group flushing. We're never getting to the point where we've kept up enough that we can take a break. And I'm wondering if that's just because of the fact that dRAID is always a full stripe write, whereas RAIDZ will write a partial stripe.
Right, and that's part of the reason for this was trying to figure out if we're looking at things side by side as a comparison, is this a valid test?
Yeah.
And as we go through further testing and designing what a full test suite looks like in the real world, where does that performance match? Right. So we can say A is B in this scenario. And that's one of the things we want to get out of this.
What's your workload look like? So dRAID was designed with larger blocks in mind, like not 128K, but really 16 meg, but even maybe 1 meg, you might see less of a drastic difference with the larger record size.
Yeah, on the spit output, we actually go up to really large blocks. Mm-hmm. So it's most of the stuff that my customer base uses is all video. So 8K level video, so it is big chunks.
Right. So are you changing the record size property on the ZFS data set that you're testing with?
No, these are consistent with the exact same.
The default 128.
Default 128, yep.
So it might be interesting to compare RAIDZ and dRAID with the record size set to 1 megabyte.
Sure.
And also, if you set primary cache to metadata, it will not give this weird effect where your read performance is faster than the drives are actually doing.
Right.
Because it will just only cache the indirect blocks and not the data. And that way the read results you get will actually reflect what an uncached read will look like.
Right. No, and these are the type of things that as the user side of this is we don't know all those pieces. Mm-hmm. And with the number of variables that are out there inside of ZFS to be able to say, hey, tweak this, tweak that, where's the right starting point saying, this is a normal RAIDZ configuration. Okay, to go to dRAID and get equivalent or better performance, hopefully better performance, start here.
Yeah.
Whatever that translator is, or happy to help write that, test it, whatever. But those are the type of things that is why we want to have this, because we've discussed it on the call multiple times, and it's.
But yeah, I think one of the advantages of dRAID is because each disk is distributed, that you would likely use less redundancy. So you'd make your RAID groups slightly wider, knowing that you're not going to have the same penalty for resilver. Right. So you would get more data in the same number of drives. The trade-off is you have to use bigger chunks to really get the performance out of it. And if you do have any small blocks, like if you do have a 16 kilobyte file that's like metadata about the video or something, that's going to take a whole stripe and waste a lot of space.
And that's the balance we're trying to figure out as well. Because that's obviously in video processing, having that metadata or even silly spreadsheets around.
Yeah, spreadsheets or a text file that has the description of the movie or whatever.
Yeah, and anything that is, again, we don't do anything in compressed in ZFS at all. Zero, none. It does us absolutely no good. So that's the first thing. Compression is off on everything that we do.
Do you have a lot of files though?
Yeah.
So some other media and entertainment companies we work with, in their workflow, like they have 8K video, but every frame is a separate 80 megabyte file.
Right.
And so they have a huge number of files. But it means that when you go to a larger record size, like if you use a 16 megabyte record size, then if you have a file that's not a multiple of 16 megabytes, that last chunk of it will take 16 megabytes, even if it's
regardless.
not. And turning on compression on these uncompressible files is expensive.
Yep.
So we have a prototype for something called slack compression that basically applies zero elimination only to that last block, and makes that one take 4 megabytes instead of 16 if the file happens to round out that way.
Right. Yeah. The RAID cameras are the notorious ones for that.
Yeah.
They generate a ton of stuff. And
yeah.
So.
And where you wouldn't have to pay the cost of compression, but would be able to get space savings. But if you're using dRAID, it doesn't make sense because you're going to write the full stripe whether the file's 4 megabytes or 16 megabytes anyway.
Right. So. Pardon?
And those are really big files.
Mm-hmm.
They're dealing with computer vision researchers. The very first thing they do when they get, video is, they write out like, 1 frame per file, but they're only like, 100K.
Mm-hmm.
So
they're doing their own thumbnails on the fly, basically.
Well, not really on the fly. It's that's what they're training their machine learning models.
Oh,
on.
the file is imported, it does a frame grab.
Yeah.
To do that. And that's normal too. I mean, so is building proxies off of original files. They're obviously much smaller. They're still representative of the video that's actually being acted upon.
As far as those little metadata type files,
Hmm?
would that be a good use case for social media?
Potentially. Sorry. Yep. Say it one more time, Andrew.
As far as the
Using a special dev to handle metadata. Right. And fortunately or unfortunately, we are restricted by how the software that is using the files wants to find the metadata. Some of them want sidecars, some want it, directly next to it. Some can look at other directories for metadata if they're not using some sort of advanced MAM that houses all of that metadata for them outside of the file itself. So the answer is yes, but no.
Like that's where the small blocks feature in ZFS for special VDEVs came from was, when we're using 16 megabyte blocks, if you do have any small files that are under a certain threshold that you configure per data set, it will store them on the special VDEV with the metadata, like the ZFS metadata, so that you can use those. You can use mirrors there and not waste a whole 16 megabyte stripe on a 4 kilobyte text file that describes what the video is,
Right.
or who owns the video or whatever.
Yeah, all the magic.
Yes.
All the magic I don't have to worry about because somebody else. That's those Patrick people that like to do video. So yeah, you can go back. So it obviously finished minutes ago, but so it's still 2 gig, 700 meg.
So
roughly
how big was the difference between the FIO, the RAIDZ, and the dRAID on the actual writes?
It's basically the time delta between 321 and 57.
Right, but the actual
The real time.
megabytes per second on writes reported by FIO.
So the first one was 2149 read, 720 write.
Yeah, 720 write, and the second one
That
is
was 2183 and 732.
yeah. So that's actually about the same speed.
Right.
Tony pointed out that it looks like most of the time delta is actually coming from FIO pre-allocating the file, not the actual writing. So there's a flag in FIO. I think it's -f allocate equals none.
Right.
And it will skip that step. Since you're just randomly writing to the file, we don't need to fill the file with junk first. And in this case, you're not really trying to test the reads because you're only ever reading
Right.
what we just wrote.
And the reason for that, and I've tried it as well, it is for consistency.
Right.
Because one, trying to figure out why it's inconsistent.
Right.
And what that performance is. So
if,
that was.
If you want to if we look at just random writes to the files that were empty to begin with, I think from these results, it looks like you would actually get the same write performance for RAIDZ and dRAID, even though in this test you're seeing wildly different performance.
Right.
because once we get rid of the allocating part of it, then we see quite different results.
Yeah, and again, the FIO stuff was to be representative here.
Mm-hmm.
After this, we can go through the spit results, and I'll provide those in the slide as well. But there are things in there, and it might be how the testing tool is, corrupting our view of it, which goes back to what's the right testing tool for us.
Well,
and configuration
FIO can be the right testing tool. Even in this test, I think if you don't do any other orchestration and just run the dRAID test a second time with the files already existing, then I think you'll see a very different result. Right?
Yes,
you're like
true.
Destroying and recreating the data set. So now that the files are pre-allocated, if you just run the dRAID again, does it take about the same amount of time as the RAIDZ?
Yes, based on previous tests.
So that makes a very interesting question of what is different about the pre-allocating workload in FIO. And I think the difference is pre-allocation in FIO is single-threaded, whereas you're running a num jobs on the actual writing.
Yeah, the actual
benchmark uses multiple threads and is able to get the same performance as RAIDZ. But when single-threaded writing, dRAID is being much worse.
Yeah, so that's the FIO test. Where's the script?
The job
I didn't paste that in properly, apparently. I just ran the run portion of it, but I will add that back into the template. So, all that being said, and Alan, thank you. And this is why we're here.
Yep.
And part of it's my ignorance, and I'm happy to learn. But trying to figure out, for newbies, anybody we bring into it, it's like, okay, what should I run? Do I run zRAID, or do I run RAIDZ, or do I run dRAID? Obviously, there's a number of device limit that you don't want to go below for dRAID. Whatever that number is, Alan. There's
not enough practical experience. That's why I'm very interested in what you're doing here.
We can break this. I've got a week left before this has to roll into production, so we can beat it all up basically through next week.
But yeah, I imagine it's somewhere like 24 to 36, where less than that you probably just want to stick to RAIDZ.
Right, and that's kind of where my line in the sand was until this conference.
But I think the big thing is if you have a lot of small blocks, then dRAID is a non-starter because it's going to use up all your space and have these giant stripes that are full of nothing.
Right. So actually, we answered most of the first one. So happy to finish the any other conversations you guys have or questions about it. But just wanted to leave you with my original thoughts on this. So the first big bullet we've already covered, and Alan's pretty much put to bed. Configuration and tuning recommendations and warnings if the feature dRAID is active versus enabled, just to say, hey, you might want to consider this as we move forward. So whether it's something in the ARC that needs to be better tuned for a dRAID environment.
I don't think there's anything I'm aware of that you want to do differently with dRAID other than realizing that every write's going to be the full stripe, and that's going to change
based upon size.
The shapes of a couple things. But
and
in case of logging, you mean ZIL writing, like synchronous writes, then probably dRAID is the worst possible scenario for ZIL, since it has to flush all the disks in a pool practically for each commit, for each transaction. So in that case, you would definitely like slog if you need synchronous writes,
right?
More than any time else. And
so if you're doing NFS with Linux clients, you definitely want to slog.
Yeah,
right. So and again, finding that right balance of, hey, I've got 204 drives out here. What should it look like? Mm-hmm. Any guidance on that, then we can then go and tune in and say, you know what, it's actually better at 80% of that or 140% of that.
Yeah, I think in your case with the larger files, probably wider VDEVs will give you more space and probably more performance. Like with the 6 wide, it's in a Z2, that's pretty narrow.
6 wide Z2 is too aggressive, but dRAID in such configuration probably doesn't make much sense, because in case of dRAID, unlike of RAIDZ with multiple VDEVs, in case of the dRAID, if you lose 3 drives out of 103 same time, you lose your pool.
Right.
So in that, if you use dRAID and you won't use it where it should probably be, it should be much wider RAIDZ groups, parity groups, or whatever we call them there, so that you would get maximum space efficiency, maximum throughput, and still you understand that losing of 3 disks is critical, but for that downside, you actually get benefits of much better space efficiency and so on.
Right.
And with RAIDZ, you can indeed afford smaller sinks, 15 smaller VDEVs, and you can lose 3 out of each,
Right.
not 3 total of them. And in that case, you can store much smaller blocks.
Right. And part of this too was trying to maintain here's a consistent
apples.
reality
Yeah.
of, how we deploy it on a 24-base system is, 4x6. It's done. I mean, that's the most efficient way through our testing and our customer base, that's how it works the best. So again, finding the right way to test it and, okay, here are the right configurations. That's what we're looking to come out with. Which brings me to...
Just before you move on,
sure.
for L2 ARC, I think with 192 gigs of RAM, you're better off putting in more RAM than an L2 ARC.
Right.
For such big ARC, you would probably need quite a lot of L2 ARC, and for that, several times recently, I'm trying to motivate somebody to actually work how L2 ARC is written. We're not very efficient on the speed of writing it.
Right.
So by the time it will get full, your system will be 6 months in production.
Right.
So maybe maybe in addition to L2 ARC, or instead, as Alan told, more RAM plus special VDEV if you need to store small files or a lot of metadata, just access metadata fast from special VDEV and do streaming from everything else.
Right.
If you have a very large file, what chance that they will land on L2 ARC, and will actually L2 ARC be able to provide you as
anything
high
useful, right?
Be useful. And it's quite often, if you have so many drives, if you have very good host connection, they could be much faster than any single SSD you put as L2 ARC.
Yes.
Even if it's NVMe.
I've broken that. Yes.
So
and to your point, Alan, and there are, we're actually deploying a system next week that has a terabyte of memory in it, doing a very similar thing. So that's obviously, this is again what we've got to test with, and here's how we're playing with it.
Like very much to Alexander's point, in addition to the default tuning for the right throttling on the L2 ARC is from the year 2005. The other problem is that L2 ARC is kind of a misnomer in that the cache device doesn't actually implement the ARC algorithm. It is just an LRU. And that's not very efficient most of the time.
there are actually a number of problems if somebody interested in quick summary. So the first, when we in ARC introduced multi-list structure to make ARC more SMP ready, L2 ARC kind of suffered from it because it writes only from one sublist each time at a time. If we have a lot of CPU cores, it means once per second we can handle only 1/64th of ARC. And then again and again, and it may, at the end, we are not writing to L2 ARC everything we could, because we just getting no data at the time. We should instead scan all the list, but equally and progressively. There are some tunings that could overcome that, some headroom, but then it will cost CPU at the end. Okay, once we get to some throughput, we should put more attention of what actually we are writing. Because right now there are options, we can write only metadata, we can write data, but again, balance is not particularly great. Also, it tries to place something about prefetch, like not writing to ALC prefetched data, but I think logic should be slightly different. What a chance, like we should probably not write into L2ARC data that were actually read into ARC before the hit, because if main storage can do it fast enough, don't write it to L2ARC.
Yeah.
Leave it to main storage, that's good enough. But if access is random, main storage can't keep up, then write it. That's another thing we should rewrite into L2ARC.
Yeah.
So there are a number of ideas I have floating around that should be done by somebody.
Yep. And all throughout the L2ARC code, there's XXX fix this in L2ARC 2.0.
Yeah. No, it's actually, I see it as 3 or 4 smaller projects. It doesn't need to be 2.0.
Yeah.
It's quite incremental
Maybe
process.
we should
I don't actually
get those
remember
written down.
What was the original point of 2.0? Was there some dramatic?
I don't. It's so long ago. I don't think anybody remembers.
But
Those lines are from early Illumos.
But to that point, is it something that will be as it's being developed, it'll be configurably, tunable by workloads?
But I think
my
your
workload's not the only
workload
one
in
I care about.
particular would just never benefit from the L2ARC.
Right. So, if that's the case, we're at a point in the
Use
hardware.
those SSDs for special videos.
Yeah, in their hardware level, hey, we don't need the complexity. Great. I'm all about reducing complexity. So whenever we can. Any other questions, concerns, comments?
Yeah.
So-
Looking at your next. Oh, sorry.
Oh.
Go ahead.
Number 4?
4.
Okay. So one of the things, and we sort of ran into this issue starting probably about 8 years ago or so, where we're really just not finding any benchmarks that look anything at all like what our user workloads look like. We went out, we licensed the spec SFS 2014 benchmark, and we did a bunch of work with that. But it's like, well, here's these canned workloads, and none of them say like machine learning or computer vision on them. And I have a better idea now of like what a computer vision workload looks like. It looks like, loading 100 million 128K files in random order. And, I'm wondering if folks have any better ideas at all about, what's a reasonable modern benchmark.
I don't know that there are many. One idea we've thought about is basically making a recorder that would sit on ZFS and record not the data, but the shapes of the blocks and the patterns that we could just replay filled out with random data in the future to basically turn a recording of any workload into a benchmark that could be repeatable. Because short of that, I don't know any benchmark tool where you could try to explain a workload and have it make something reasonable.
Yes, please. Please.
There is no benchmark better than your actual workload.
So repeating the comment, what's your name?
I was just saying.
Your name.
Andrew.
Oh, Andrew.
Andrew from the VAC mentions that no benchmark is going to match your real world workload. So being able to record 5 minutes of your real world workload and be able to repeat that in your lab environment and tune it until it works how you want is the only way to actually have a real benchmark of your workload. A lot of times with FIO, we're just trying to recreate the worst case workload and make it good enough and hope it'll work. But being able to, especially if you want to tune something like the cache, like if you're trying to decide how to get the most caching efficiency, having a workload that's more realistic than either just all random data that we're accessing completely randomly or whatever, or if you want to benchmark prefetch, it'd be much easier to do that repeatedly if you have a sample of a bunch of different workloads or different kinds of workloads, and being able to tell objectively this way of doing prefetch is better for all these workloads or 80% of these workloads, rather than it worked well for the tests that I could think of.
Yeah, I think, having something like that, in particular, that we could publish and say to, file system developers or vendors or whomever, hey, this is what our workload looks like. Please tell us what to do, or please make your system perform better on this workload.
Yeah, and kind of to the bullet point here, on FreeBSD we have Olivier Couchard-Lebet maintains a repo called NetBenches, where he has a bunch of firewall benchmarks that he does, and there's a subdirectory for each different hardware platform he's tried it on, and then it shows like the different versions of FreeBSD he tried it on, and so you can actually see the performance of this same workload across revisions of FreeBSD, and a commit that made the firewall 20% better, and so on. And I'd really like to have a bunch of these workloads and these kind of graphs with ZFS is saying, yeah, when Mav made that commit, everybody's workload got 10% better. This is great. Or, hey, we saw with this commit, there was a regression on this specific workload. Can we, make it not as bad? And while at the same time, not having to just give up the benefits that every other workload did get from that commit, and being able to track, performance over time just to tell when we've made changes or when things have gotten crazy. Yeah, so Rod's comment was, again, back to what we were just talking about. You almost need something where you could capture packet flows and be able to replay them. And yeah, like something that on the storage level.
Something, one idea would be like BPF trace, where you can just trace all the IOs.
Yeah, so something like BPF trace or dtrace, or I think there's block trace or something on Linux where you can kind of get these kind of heat maps of where on the drive things are being written and so on, and being able to try to recreate similar patterns in a reproducible way.
About version comparison, we are doing that part of TrueNAS development. We have a team of 3 people doing just benchmarking 24/7, not but at least 5 days a week. Yeah. But system running 24/7 actually non-stop in order to handle each release in each 6 months, full qualification of half dozen different system in half dozen different benchmarks, with ability to say, okay, here we got some slightly better, why? Here got worse again, why? Can we do something about that point? So we are doing that, but that's quite an effort. It's definitely not something that can be run automatically without human presence.
Yeah, and how can we make it so that somebody could do this by themselves without needing a whole team as well? And yeah, the answer is it's complicated, especially when you get to the asking why part.
Like the data collection side of it and saying, hey, workload, here's my workload, here's how things are working for me in this environment. Being able to collect and consolidate that information in a single community-ish fashion is something that I personally think would be fantastic if we can get behind it.
Yeah.
Yes, sir.
So what was the motivation of doing this test for C-RAID versus dRAID? Is it some specific?
The motivation
Repeat
for
the question for the stream.
So the question was, what's the motivation for defining whether to do dRAID or go against RAIDZ? One, I've got some big arrays, and they're really challenging to do maintenance on. And if I've got dynamic spares that are built in, that changes my operational costs. If the performance is within an acceptable point of how things operate now on RAIDZ, and they work on dRAID just as well, or in that realm, do it all day. It simplifies my life and my team's life of, hey, I only have to go on site physically, twice a year versus every 2 weeks or every, depending on what the drive cycle is, which varies on device type.
So yeah, the big caveat I will put there is, as Mav mentioned with dRAID, if you make it a dRAID 2, if you lose 2 drives, you have no redundancy left. Out of 2 out of the whole 78 or 102.
Right.
Whereas with RAIDZ, you're going to, as long as the 2 you lose aren't both in the same VDEV, you won't have to necessarily do a site visit yet.
Right.
And so really the advantage to dRAID is going to be make them wider without the resilver time going to the moon. And like you said, the dynamic spares mean that, when one does fail, you can hopefully replace it quickly enough. But in order to get the level of redundancy you need, you might need to go
It
with
gets
dRAID
much
3.
wider. Yeah.
A wider VDEV, but also a dRAID 3 so that you can get closer to how likely a failure is.
Right.
That you're getting with RAIDZ, where, while you have the RAIDZ is going to end up with the same amount of parity, but that parity being more useful because it's separate VDEVs than with dRAID.
Yep. And again, this goes back to what this demo was just for a apples to apples comparison.
Yeah.
Reality is what reality is, and that's where we take that guidance and go. So I could test it the other way with that 18, is it 16 or 18 drive limit on the VDEV right now?
Right now you're doing 15 VDEVs of 6 each, and we would suggest making it wider.
Yeah. No, but
whatever number works out to the right.
There was a hard limit in dRAID or in RAIDZ on number of devices per VDEV, wasn't there?
I don't think there's a hard limit. I think. Yeah, it's 255 or something. But don't go that wide, please.
I thought it was 16. I thought it was 16 or 18 on something I read. I haven't tested it.
I probably wouldn't suggest going over 16 or 18, just because the resilver time would possibly be immense. But nothing in ZFS stops you from doing something silly, because that would also stop you doing something clever.
Right. So.
The Unix.
Excellent. So that's all I've got. You guys have any other conversations? Wide open. Otherwise, I have no idea what the clock is. Right on time. Who knew?
Still 20 minutes to lunch, so we can socialize, take a break, whatever.
Yep. Excellent.
For companies that already have systems that are already set up based on Stew Redfield, I was trying to figure out how to package and encourage them towards the OpenZFS direction. How would you approach that? Trying to help explain to people this is really a new direction.
Honestly, I think it's a great question, but I think the best time to do that is this afternoon.
Yeah, okay, fair enough.
Because we have a session just around that, and tuning that up into, or serving that up to, hey, this is how we sell OpenZFS philosophically and financially, depending on, or as a service. So I think that's a better time for it, but great question. How can we make your life better? Yes.
Oh, sorry. Okay, anyway, I'm done talking now.
Patrick doesn't move as fast as he does.
Yes. But yeah, I think kind of to that point, the biggest thing is I don't think anybody's in love with their hardware RAID controller.
No.
Especially if they've ever had one fail and tried to replace it.
That's 8 years old.
The issue that I saw a customer have lately is, they had their separate HPA, but somehow the RAID one took over when they reseeded some stuff, and it decided that there should be an invalid MBR partition written to every disk. And then their pool wouldn't import anymore because the label was clobbered. And we had to recreate the right partitions, and ZFS could find the pool again, but it was... The evil things that hardware RAID controllers do is usually enough to convince people, especially if they ever have any pool that's, more than 8 drives. Then as soon as you're looking at something like that, it's like, I want a lot more control over what's happening here and visibility on what's happening as well.
And it's not all about vendor Kool-Aid.
And I think sort of related to that is that, we've seen in recent years, like certainly in like the years that I've been doing this, we have a lot more extra CPU sitting around on these servers now that can be put to better use. We don't need to hardware offload everything because, it's a 64 core server. It can just do it,
Yeah, the ones we were working with recently were AMD systems with 512 threads.
Excellent.
I can tell you, we have a hard policy that if it doesn't go to HBA mode,
Okay, so Andy was saying, at his place of work, they have a policy that if the card can't be dumbed down to an HBA, then they don't use it. And that's a good policy.
Absolutely. Excellent. Thank you all.